So continuing on with some of our techniques used for differentiation, in this video we're going to be focusing on the quotient rule. So this is when you have some sort of function, let's say h of x, and if you see in this function that there's two very distinctive little mini functions, you can say. So if you can differentiate the top, you can differentiate the bottom as well, then there's actually a rule for this. So this is when the whole fraction here, f on g, is really hard to differentiate altogether. You just want to work on the top and bottom separately. So the derivative h dash of x in function notation would be to take the derivative of the first, the derivative of the numerator first. So f dash over here, you're going to leave g of x. So I'm just going to color code this as we go. So whenever I leave something, I'm just going to say I'm going to write this in blue. And you want to subtract by the product of leaving the numerator as it is, and then you want to differentiate the denominator. And at the bottom, you always have the denominator squared, so you don't really need to do the derivative or anything down here. So alternatively, of course, you can write this using this kind of notation over here. So if you imagine that your numerator is some substitution using u, and you substitute using v at the bottom, then dy dx, or derivative function, whatever you want to call it, is going to be the numerator differentiated. So same pattern over here. Differentiate the numerator first and differentiate the denominator last. And you're going to leave the denominator first and leave the numerator second. Now it's important that we know the order here, because unlike the product rule, we have a subtraction in between two products. So this means that it's really important which product is subtracting from which. Unlike the product rule, if you plus, then it doesn't really matter which order you go in. So this is pretty much why we like to think of the first function, so f of x, the numerator, or the first function in line for the product rule is going to be differentiated first, just to stay consistent with this rule over here. So we'll go through an example. Now, we know the derivative of 10x. Now, this one here, you know from previous videos that we're going to end up with 1 on cos squared x, or sec squared. Okay, but where does this actually come from? And this is what we're going to talk about. So what we're going to do is we're going to say that h of x is equal to sine x on cos x. And from here, we're going to use the quotient rule to figure out how we can get dy dx, or I should say, in this case, it should be h dash of x. Just rub this out. Maybe I'll get a bigger brush. Make this a lot easier. Okay. So this is h dash. And we're going to try to see, using the quotient rule, see if we can get it down to 1 on cos squared. Okay, so h dash is going to be, so first of all, we know that we have to take the derivative of the numerator first. So I'm going to do this in green. We're going to have the derivative of sine cos x, and then we're going to leave the denominator. So g of x comes next. Cos x. After that, we're going to leave our numerator. So leaving the numerator will give us sine x. And differentiating the denominator over here is going to give us negative sine x. Now, since this is the case over here, we're leaving sine x here, so let's just go back and color this in blue. This is sine x. Left alone. Scroll across here a little bit. and we're going to have negative sine x here when we differentiate the denominator cos x. And right at the bottom, we're going to end up with the denominator square, which is cos x. But if you want to square this whole term over here, we just put the square right in the middle. Okay, so if we scroll down a little bit, now we just need to simplify this. Note that with the two positives here, you can actually say it's a double negative. So what we're going to do is we're just going to say that since you're multiplying two negatives, we're going to have a plus. At the top, we end up with cos squared x plus sine squared x. Or over cos squared. Now remember that through our trig identities, we know that sine squared plus cos squared, if they have the same angle, then that means, so if these two are the same, then this means this is equal to 1. So our numerator up here is equal to 1. So that's why we're just left with 1 on the cos squared x. And this is pretty much the same result as what we got up above here. Okay, so we'll do something a little bit more tricky. So what I mean by tricky is it's really difficult to do without the quotient rule. Now, I say difficult because you can still do this without the quotient rule, because what you can do here is polynomial division, but we're going to try it out. Just practice using the quotient rule a little bit here. So what we're going to do is we're going to say that the top is f of x cubed plus 2x, and the bottom is x squared minus 5x plus 7. Okay, so when you figure out what h dash is, what we're going to do is, so remember, we're going to differentiate the top first. So f dash over here is going to be differentiated. So this one is going to be 3x squared plus 2x, plus 2. And we're going to leave g of x. So this is where I'm just going to write this in blue. So I'm going to leave it as it is. X squared minus 5x plus 7. We want to subtract by, let's see, so we're going to leave f of x this time, because we differentiated x cubed plus 2x before. This time we're going to leave it. Just leave it alone. Okay, g of x, this is, it's time to shine. So we're going to have the derivative of g of x, so x squared turns to 2x, minus 5x will give you minus 5. And all this, just draw one big line, straight as you can. Okay, that's probably not my best effort. And we're going to have this all over x squared minus 5x plus 7 all squared. Okay, so if you can see that you can simplify, please do. But a lot of the time, you may just want to leave it in this factorized form. You can see that you can separate this into two fractions. So the two fractions will be separated by this minus sign over here, and they both have a denominator of, well, this down here. And you can cancel these two out to a certain extent. So you just turn this index into 1, and this gets cancelled completely. But of course, this leaves the denominator of x squared minus 5x plus 7 squared for the other fraction. So there isn't actually too much merit into further simplifying this. This has already got a factorized numerator as well as a denominator, which is common between the two. So we're just going to leave it at this. Okay. So over here, now, very similar scenario. We do have a denominator which is a little bit more complicated, but it just means we have a couple more steps. It doesn't actually mean it's more difficult, it just means that the process is a little bit longer. So again, going to let our numerator equal to f of x, and our denominator as square root of 2 minus 5x squared. But let's just put this into index form. Just remember that it's a lot easier to differentiate any square roots that you might encounter using this half index instead. So now we can differentiate by saying that we're going to differentiate the numerator first. So 3e to the 2x. What's the derivative of this? Well, it's 3 multiplied by 2. So we bring the derivative of the index down. This base and index stay the same. Okay. From here, we're going to leave g of x. So 2 minus 5x squared half, or square root. Deal with it a little bit later on. And let's see over here. I think I'll just move to another line down here. Good. I don't think we're going to have enough room. So let me subtract it by, what do we have? Just put the minus sign over here. So we're going to leave f of x in this case, because we differentiated last time. And we're going to differentiate 2 minus 5x squared now to the power of half. So differentiating this will give us half multiplied by 2 minus 5x squared to the power of negative half now, subtracting the index by 1. So notice here we're using the chain rule, and we made a substitution for this inside over here, this u. So what you need to do is you need to multiply by du dx, which is the derivative of, well, 2 minus 5x squared, give you negative 10x. Okay, so before we all put this all together, of course, just remember that we're not done here. All of this is just the product of the difference of the two products is all divided by g of x squared. So g of x is this. Now if you have g of x squared, let's have a look let's have a look at what happens. So we have this to the power of half, but it's squared. So as you may know, that when you have a square root squared, you're going to be cancelling the square root out. But you can do this using index laws, of course, because half times 2 is just equal to 1. Okay. Not sure why I'm writing this down. I'm sure most of you already know this. Okay. Anyway, going ahead a little bit, just keep what we did on the screen. Okay. So over here, we got 6e to the 2x. Start writing some square roots here. 2 minus 5x squared. Okay, what's this chunk over here? Let's recognize that there's two negatives over here. So we're going to account for the double negative and make it positive. We got 3e to the 2x multiplied by 10x. Okay, so we'll combine the 3 and 10 in the next step, as well as this half. So we have half 2 minus 5x squared or over 2 minus 5x squared. Okay. So from here, a couple of things you can do. Now, we can combine this 3, 10, and half together. So we can do that. But there's also, actually, no, we'll just write that down first. There's a few steps you can do. So just rewriting the first term. And over here, 30 times half is 15. So we have 15 e to the 2x, 2 minus 5x squared, or over 2 minus 5x squared. Okay, so as I hinted before, a few things you can do over here just to make it more presentable. One thing to do is you can factorize the e to the 2x and the 6 and 15 to a certain extent. So first thing to do, the obvious factor is e to the 2x, and between 6 and 15 you can take a factor of 3 out. So you end up back with, so you just end up with 2 for the first one. So maybe I'll just do this in a different color. So over here, when I turn this, when I took the 3 out, this one turned into 2. Okay, and this 15 turns into 5. So that's where the 3 comes from. So we're going to have a 2 here. And this e to the 2x is taken to the front. And 2 minus 5x squared plus, that's just 5. 2 minus 5x squared. Oops. Two minus 5x squared over here as well. Okay. Alright, and you can do a bit more cancelling actually. So right at the bottom here, you can see that you got square root of 2 minus 5x squared. You got 2 minus 5x squared here as well. So the thing here to do is you can divide the top and bottom by square root of 2 minus 5x squared. Or in other words, divide by 2 minus 5x squared to the power of half. And when you do this, the top will just be left with 2. So naturally, if you divide this first term over here by the square root of 2 minus 5x squared, this minus over here, that you're going to left with 2. Dividing this one over here, now this has an index of 1. And if you divide by the same bracket term to the power of half, you're subtracting this index by half. So that's a pretty ugly looking 1. So let me just redraw that. We get 1. So minus 5. Now it's got an index of half, so square root is the same thing. And the denominator also gets divided by this as well. So 2 minus 5x squared down here. Okay, so just clean up a little bit. I mean, you may not need to go through all of these steps, but this is probably the most presentable form you can have in terms of presenting the derivative of what we had right at the beginning, which was somewhere up here. There we go. And yeah, that's pretty much how you do it.